demonstrate to you to begin with is that a cathode ray oscilloscope, or an oscilloscope, is simply a voltmeter. To start with, I have a traditional moving coil voltmeter, which I've adjusted so that it centres in the middle of the display. And as I put a slowly varying voltage on that, it will swing up. In this case, the voltage is going up to positive 5 volts, back through 0, and then down to negative 5 volts. And that voltage is varying at 0.1 of a hertz, 1/10 of a cycle per second. So that means a full cycle of the motion is basically 10 seconds. So it's taking that voltage in 10 seconds to go through a full cycle. Now here I have a digital oscilloscope, and I'm going to turn it on and let it run. I've got this oscilloscope adjusted so that 0 volts is across the centre of the screen. As the voltage goes up to plus 5 volts, it goes up to there, goes down to 0 volts, it goes down to minus 5 volts, and back to 0 volts. And what you can see there is, as well as measuring voltage, the oscilloscope is drawing us a graph of voltage as a function of time. I have the horizontal scale on this oscilloscope at the moment set so that 1 centimetre across the scale is 2.5 seconds. So that means 10 seconds is 4 centimetres. And over a period of 10 seconds, the trace will go up and down, complete a full cycle of motion. That distance from there to there, 4 centimetres, corresponds to 10 seconds. And so I can see the voltage as a function of time. And what the digital oscilloscope is doing is that as it redraws the graph, it wipes out its previous graph and then draws the new graph leading on there. Now what I'm going to do is increase the frequency a bit. Let's go up in frequency a bit to 0.5 MHz. The moving coil meter is having a bit of trouble now. It's actually overshooting as it swings backwards and forwards. But it's still valiantly trying to keep up and show us that there is a varying voltage there. Now 0.5 of the hertz, or half a cycle per second, is 1 full cycle every 2 seconds. And you can now see the oscilloscope is drawing a graph that's going positive and negative once every 2 seconds. What I can do to make that a little clearer is make the trace move a little bit more quickly across the screen. I've now adjusted that so I have 500 milliseconds, or half a second is 1 centimetre across the screen. So 4 half seconds is 2 seconds, 4 centimetres across the screen is 2 seconds. And you can see voltage as a function of time being continually redrawn across the screen of the oscilloscope. Still going between its plus 5 volts and minus 5 volts, but now moving somewhat more quickly. Let's go to an even higher frequency. Let's take the digits down in there to 0. At the moment I have a DC voltage of about 5 volts, a straight horizontal trace across the screen. No change at all. Let's select a different digit in the ones column, and we'll go up to 2 cycles per second, 2 hertz, 2 oscillations in a second. And you can see the oscilloscope is still happily managing to keep up, redrawing its trace between the plus 5 volts and the minus 5 volts. The advantage of this oscilloscope is that it can go up to 25 megahertz, 25 million cycles per second, whereas the moving coil meter is basically not even keeping up at 2 hertz. So if I go to an even higher frequency, so 8 cycles per second, the moving coil meter has just about given up. You can barely see a flicker in the needle. The oscilloscope is happily drawing its graph. So we simply need to make the scale along the time axis expanded out, which is basically the trace moving more quickly. If I go fast enough, at this speed you can see the trace is drawing itself and redrawing itself. I'm on the 100 milliseconds per centimetre. A tenth of a second is 1 centimetre on that scale. If I go much faster than that, it redraws itself so rapidly you can no longer see that it's wiping itself out and redrawing itself. But we still have here, for a repetitive voltage, a graph of voltage as a function of time. So we can go to an even higher frequency. Let's go back down to DC. let's select a different digit. That is 1000 cycles per second. I simply need to make the oscilloscope go much faster. And on this graph now, I've got 250 microseconds per centimetre. So 4 times 250 is 1000. 1000 microseconds is a millisecond, which is the period of this signal. This is now going at 1000 cycles per second. And now, 1,000th of a second is from there to there. We can see the voltage goes positive and negative. So all the oscilloscope is doing for us is drawing a graph of voltage as a function of time. And what we've got to learn how to do is basically how to use it to measure voltage and how to use it to measure time.